We often think about science, about philosophy, and we trace it back, through the big names, Plato, Aristotle, maybe Newton, Galileo. But imagine going even further back, way further, to this single, almost kind of forgotten moment, when the very first questions about, like, what is reality actually made of were first asked, a time before all these formal disciplines we have now. When, well, the world was explained mostly by stories, gods, spirits, divine acts causing everything. What if, in that world, in this really busy ancient city, a few people dared to ask a completely different kind of question? Not who made the world, but what is the world fundamentally made of? So today we're really diving into that, exploring these foundational ideas, the radical thinking of what's called the Milesian School. And this isn't just, dusty old books. It's about that electrifying moment when Western philosophy, and maybe even science itself, first kind of flickered into life. We're going to unpack the ideas of three pretty remarkable thinkers: Thales, Anaximanders, and Anaximenes.
Right. And our sources for this, they're basically excerpts from historical philosophical texts.
Yeah.
They kind of distill centuries of thinking about these really key figures. They give us this rare but surprisingly detailed look into what was going on intellectually in ancient Ionia, what these specific philosophers were arguing for. It's a fascinating window, really, into how people first started tackling these huge questions about existence using reason, systematic reason, instead of just, well, myths, which were compelling, sure, but not really based on observation.
Exactly. So our mission today is to unpack these ancient ideas, pull out the core thinking, and understand not just what they believed, but why it was so profound back then, and why the questions they asked still kind of echo today in our own search for knowledge. Get ready for some surprising connections and maybe some deep thoughts about where our whole intellectual tradition started. So let's kick things off in the city where it all began. Okay, let's unpack Miletus. It's the city in ancient Ionia, right, coast of modern Turkey. But when we think Greek philosophy, usually Athens jumps to mind first. So why Miletus? Why there and not Athens right away? What was so special about this place?
That's a really crucial question. And yeah, the city itself is a huge part of the answer. Miletus wasn't just some average ancient city. It was exceptional. It was a flourishing commercial powerhouse in Asia Minor, a major port in Ionia. Its location was key. It was a hub for massive trade connections, not just with other Greek cities, but importantly, with powerful, intellectually advanced neighbors like Lydia, the Persian Empire, even Egypt and Mesopotamia way down the line.
Ah, okay. So this constant stream of goods coming in and out also meant a stream of ideas, like a marketplace for thoughts as well as things.
Exactly. Imagine this vibrant marketplace, not just for olive oil and pottery, but a kind of bazaar for concepts, different observations, new ways of seeing the world. This commercial energy, this exposure to so many different cultures. Think about Babylonian astronomy, which was incredibly advanced for the time, or Egyptian geometry, vital for their building and surveying.
Yeah.
All this likely created an environment that was just ripe for intellectual curiosity, for exchanging ideas. Miletus was probably less bound by tradition, by sort of insular beliefs, because its people, especially this rising merchant class, were constantly encountering new perspectives.
New explanations for how the world works, maybe.
Right. New explanations, new kinds of knowledge. It encourages questioning the old ways, an openness that maybe wasn't possible in more isolated places. It created this intellectual friction, you could say, that could spark really new thinking.
And the politics there were changing too, right? Not static. How did that play into it? The shifts in power between different groups?
Absolutely. The political and social side was vital. Miletus saw big political shifts over time, like many Greek cities. It moved from a landowning aristocracy power held by a few old wealthy families towards a plutocracy that's ruled by the wealthy, specifically the merchants who were becoming more and more powerful. Then it had periods of tyranny, often led by figures like Thrasybulus, maybe coming from that merchant class. And eventually it moved towards more democratic or republican setups. This constant change meant power wasn't fixed. New voices, new ways of thinking could actually gain some traction.
That's really interesting. So how does a merchant class who values practical knowledge, maybe innovation for trade, differ in its approach to, well, truth compared to a landowning aristocracy that might value tradition more?
That's a great point, and it gets to what kinds of knowledge get valued. A traditional aristocracy often relies on inherited wisdom, stability, and ancestral lines, the status quo. Their power is tied to land, established religion, fixed social roles. Truth might be seen as something revealed, passed down. But a merchant class, they operate in a dynamic, unpredictable world. Their success depends on practical knowledge, reading markets, weather, navigating accurately, understanding different people, adapting. They value innovation, foresight, calculation, solving real problems. Their whole livelihood depends on understanding the observable world, on practical solutions, on, well, rational thinking.
Makes sense. That mindset seems much more likely to question old myths, right? To look for principles that work everywhere, not just rely on local gods or stories.
Exactly. It fosters a spirit of rational inquiry. It's more conducive to seeking universal observable principles.
And you mentioned something else key earlier. This is before the big influence of certain religious movements that came later in Greece, like Orphism or the Dionysian cults.
Yes, that's critical. What's fascinating is that these first Milesians, Thales, and the others seem almost untouched by those later, often more mystical or cult-like movements. It suggests they were on a unique kind of independent path of inquiry, which makes you wonder, right? Did their focus on the natural world happen because there wasn't this strong mythological framework dictating all the answers? Or did their naturalistic way of thinking actually help create some distance from those traditional explanations?
That's a chicken and egg question almost.
It is, but clearly their emphasis was on natural stuff, on observation, on the idea of an inherent order in the universe, not, God's pulling all the strings day to day. This intellectual space, relatively free from really entrenched religious dogma, allowed them to ask fundamentally new kinds of questions.
Okay, so this is where it gets really wild. The paradigm shift itself. Before these guys, explanations for, well, everything, sunrise, flood, storms, it was all myths, right? Gods and goddesses doing things. Zeus throws lightning, Poseidon shakes the sea. It's hard to even imagine thinking differently back then. So when the Milesians shifted the question from who did it to what's it made of,
Yeah.
what were the implications, that feels huge, potentially even dangerous.
Oh, it was an intellectual earthquake. Yeah, absolutely. It wasn't just offering a different answer. It was fundamentally changing what counted as an explanation and where the authority for that explanation came from. To suggest the universe ran on its own inherent principles, principles you could figure out with reason and observation rather than divine whims, well, that takes the gods out of the driver's seat, doesn't it? It suggests a universe that's understandable, maybe predictable, maybe even something humans could influence through understanding. That's a massive step towards science. But yeah, also a challenge to the established order that relied on divine authority, on priests interpreting the God's will.
So their core mission, you said, was finding the arch, this fundamental stuff.
Yes, the arch, a Greek term meaning the origin, the fundamental unchanging substance or principle from which everything else comes. This was a huge departure from anthropomorphic gods, gods with human traits controlling things. It was a shift toward a more rational, observable, and eventually scientific view of the cosmos. They were looking for underlying, unifying principles, not just more stories about gods. This search for one single basic stuff behind all the diversity we see, that was revolutionary.
Right. So let's get into the first of these thinkers, Thales of Miletus, often called the very first philosopher. And his big idea, his arch, was water. Everything is made of water. Okay, so water. It sounds, I don't know, almost too simple to us now with chemistry and physics. Why water? What was he seeing?
It does sound simple now, doesn't it? But the radical part was that it was a natural explanation, not a myth. And Thales wasn't just, pulling it out of thin air. He was observing. He was hypothesizing. Our sources, mainly Aristotle looking back, suggest a very rational, almost proto-scientific thought process. He saw that water is crucial for all life. As Aristotle put it, everything is fed by moisture. Plants, animals, us, we all need water. He noticed that heat seems to generate moisture. Think evaporation. And that living things seem to come from moisture, like seeds sprouting in damp earth.
Okay, I can see the observational links there. Life needs water.
Right. And there's more. He likely held the view, common in Near Eastern ideas he might have encountered through Miletus's trade, that the earth itself rests on water, like a big raft on an ocean. Maybe observations of islands, coasts, maybe even earthquake tremors reinforce this idea of water underneath. And there's this other interesting bit. He apparently thought even things like magnets have a kind of soul or power to move things, relating it somehow to moisture or a life-giving spirit.
A magnet having a soul. That's different.
It sounds strange, but it shows he was looking for a unifying principle of life and motion everywhere. But the key thing with water was its changeability. He saw water as liquid, obviously, but it freezes into a solid ice, and it disappears into a gas, vapor, or steam. Plus, it's everywhere: seas, rivers, rain, the moisture in living things. So he saw this one substance taking many forms and being fundamental to life. It was this attempt to unify all these different things under one observable natural principle. That's really the core of early scientific thinking, trying to explain the many from the one.
And he wasn't just sitting around thinking abstract thoughts, was he? The stories paint him as this practical guy, too. Scientist, mathematician. There's the famous eclipse prediction, measuring pyramids. How do these practical skills connect to his philosophy? Did knowing how to measure things make him more confident the world was orderly?
That's an excellent connection. His practical achievements definitely seem to bolster his philosophical view. That eclipse prediction, May 28, 585 BC, is legendary. Now, scholars debate exactly how he predicted it. Was it a precise calculation using advanced Babylonian tables he might have accessed? Or more of a general estimate based on known eclipse cycles? But honestly, the fact that he even attempted it is what's so significant.
Right, it shows he thought it could be predicted, that the cosmos wasn't just random.
Exactly. It shows a deep belief in an ordered, predictable universe, governed by laws that humans could figure out, not just divine whims. And trying to predict something like an eclipse, probably involving knowledge shared with Lydian or Babylonian astronomers through those trade routes, it highlights that intellectual exchange. It showed confidence that the universe was understandable. And a public feat like that, it would surely lend weight to his ideas about a natural ordered reality.
And the geometry from Egypt, he apparently brought that to the Greeks. What did he do with it? This wasn't just theory for him, right?
No, definitely not just theory. He's credited with introducing geometry, or at least its systematic study, to Greece. And he showed its immediate practical uses, which would be vital in a trading city like Miletus. For instance, they say he figured out how to calculate the distance of a ship at sea. He'd observe it from 2 different points on land and use basic geometry, similar triangles, to work it out.
Wow, okay. That's incredibly useful for shipping or defense.
Hugely useful. And the other famous one is measuring the height of pyramids using their shadows. Such an elegant application of similar triangles again, he'd just wait until the moment his own shadow was exactly as long as he was tall. At that specific moment, he knew the pyramid's height must be equal to the length of its shadow. Simple, but brilliant.
That is clever. So these practical uses, they must have reinforced the idea that the world works on rational, maybe mathematical principles you could discover and use.
Absolutely. It cemented the idea that abstract reasoning, like geometry, could be applied to solve real-world problems and get verifiable answers. It showed that the world wasn't just chaotic myth, but had an underlying discoverable structure.
Which brings us to that great story about the olive presses. It shows he wasn't just some detached thinker. He could play the game, so to speak. He gets mocked for being a poor philosopher, and then boom, he makes a fortune predicting the olive harvest. It sounds like ancient insider trading based on astronomy.
It's a fantastic anecdote, isn't it? And it perfectly captures him. He was known as one of the 7 wise men of Greece, famed for practical wisdom. His saying, "water is best," ties back to his philosophy. But the olive press story shows his applied intelligence. Apparently, people reproached him for being poor, maybe saying philosophy was useless, couldn't earn you a living. So using his knowledge of astronomy, his observations, maybe info from Babylon about weather cycles, he predicted a huge olive harvest was coming, way before anyone else saw it. Then, while it was still the off-season and cheap, he quietly put down deposits to lease all the olive presses in Miletus and nearby Chios.
He cornered the market.
Pretty much. When the massive harvest came in exactly as he predicted, everyone suddenly needed presses. Demand shot up. He held the monopoly and could rent them out at whatever price he liked. Made it killing. It showed that philosophy, understanding the world's patterns, wasn't just abstract. It could have very real, practical, even profitable results. It was a powerful demonstration that knowledge is power, silencing his critics.
Okay, so Thales sets the stage with water and this blend of observation and practicality. Then comes his student, or associate, Anaximander. And Anaximander looks at water and says, nope, not specific enough, or too specific. He proposes the apeiron, the boundless, the infinite, the indeterminate. That sounds way more abstract.
It is a huge philosophical leap, a move towards much greater abstraction.
Yeah.
Anaximander saw a logical problem with Thales's water idea, or really with any specific element being the ultimate source.
Yeah.
He reasoned, look, if the primary stuff was, say, water, wouldn't it eventually overwhelm everything else? Water puts out fire, fire dries up water. These elements seem to be in opposition. If one of them was the source of all the others, how could the others even exist? The source element should have dominated long ago.
Ah, okay, so if everything came from water, why isn't everything just sake? Why is there fire?
Exactly. That's the problem he saw. So his solution, the apeiron, is genius because it's not any of the elements we see. Think of it as this undifferentiated, primordial something. It's not hot or cold or wet or dry itself, but it's the source from which all those qualities emerge, kind of separating out. It's this neutral, eternal, inexhaustible source that neatly sidesteps the problem of one element dominating. It's the ultimate potential, you might say.
Wow, that requires some serious abstract thinking.
It really does. It moves philosophy onto a higher level of analysis, identifying logical inconsistencies and simpler explanations. The apron is boundless, limitless, truly fundamental.
And he had this idea about cosmic justice, too. Things making reparation to each other. What's that about? It sounds almost like the elements are paying fines to each other.
It does sound poetic, but it's a deeply insightful concept about natural balance. Anaximander saw the elements, or maybe the fundamental opposites, like hot, cold, wet, dry, as constantly encroaching on each other. That's the injustice. Fire tries to consume, water tries to extinguish. But the epiron, as the underlying principle, ensures there's this cosmic justice. These forces are held in check, they balance out over time, according to the ordering of time. It's like an early concept of natural law. The universe has this inherent tendency towards equilibrium. It regulates itself. It's not God stepping in to fix things. The balance is built into the system.
A self-regulating cosmos. That's radical for the time.
Absolutely. Order comes from within nature, not imposed from outside by deities.
Okay, so beyond the super abstract apron, Anaximander was also doing cosmology, biology. He thought the Earth was a cylinder, floating freely, no water raft like Thales thought, just
Yeah.
hanging there.
Yes. That's another mind-blowing leap. Forget the raft on water, forget giant turtles or anything holding it up. Anaximander proposed the Earth as a short cylinder, like a drum, floating freely in the center of the cosmos. His reasoning, apparently, was that since it's equidistant from all points of the heavens, there's no reason for it to fall in any particular direction. It's held in place by equilibrium.
Wow. So kind of like an early intuition about gravity, or at least balance without having the concept. That takes serious imagination.
Extraordinary imagination and abstract reasoning
Right.
to conceive of the Earth just hanging there, unsupported. It broke completely from all previous, more tangible models. It's pure deduction, pushing beyond what you can directly see.
And he made the first map of the whole known world. Again, that feels practical, but also requires a huge conceptual leap, right? Representing the world systematically.
Indeed. He's credited as the first Greek to draw a map of the inhabited world, the oikumene. Think about what that involves. It's not just sketching. It requires gathering vast amounts of geographical information, probably from Miletus' sailors and traders, then synthesizing it, figuring out scales and relationships, and representing that 3D reality on a 2D surface. It's a massive exercise in applied geometry and spatial reasoning. It shows this drive to organize knowledge, to make the world understandable and representable in a systematic way, a tool for understanding.
Okay, this is maybe the most startling part for me. His ideas about life's origins, like a kind of evolution. Humans coming from fish-like creatures. That sounds incredibly ahead of its time.
It really does, doesn't it? And it really highlights just how far his naturalistic thinking went. He proposed that life first arose from the moist element, maybe mud or slime warmed by the sun, and then this really prescient bit. He considered humans. He noted how helpless human infants are, how long they need parental care compared to other animals. He reasoned that humans couldn't possibly have survived in the beginning if they just appeared on land as infants. So he speculated that they must have first developed inside some other kind of creature, specifically fish-like creatures, protected in the water. They stayed inside, he thought, until they reached puberty, essentially, and were strong enough to fend for themselves, and only then did they emerge onto land.
That is, wow. Okay, it's not Darwin, obviously, but the core idea looking for a natural process, a developmental sequence to explain where humans came from instead of just saying the gods made us. That's the amazing part.
Exactly. It's a stunning example of naturalistic thinking. He's seeking natural causes, sequential development, adaptation almost, to explain life's origins and even our specific human characteristics, like our long dependency. This is a very, very early, crude form of evolutionary thinking, searching for mechanisms within nature itself.
And he even tried to measure the cosmos, estimate sizes of the sun and moon.
Yes, he did. He estimated the sun was 27 times the size of the Earth and the moon 19 times. Now, those numbers are way off by our standards. But again, the significance isn't the accuracy. It's the attempt to quantify the cosmos, to apply number and measurement to the heavens. He was moving beyond just qualitative descriptions, the sun is bright, towards trying to grasp the universe in terms of size and proportion. It is a foundational step for astronomy as a quantitative science.
Okay, so from Thales' water to Anaximander's incredibly abstract apeiron and these startling biological ideas, we get to the third Milesian, Anaximenes. And he brings it back to a specific element again, air. So water, boundless, now air.
Is this like Going backwards from Anaximander's big abstract idea? Or
Yeah.
is it something else? What was his thinking?
That's the question, isn't it? Is it a step back
Yeah.
or maybe a refinement? I think you can strongly argue it's a crucial refinement. Anaximenes, who came after Anaximander, maybe his student, proposed air as the arch. His reasoning seems grounded in observation again, maybe even more directly than Thales. Air is everywhere, obviously. It's constantly moving, and it's absolutely essential for life. We breathe it. He made this powerful connection. Our soul, the thing that gives us life and holds us together, is breath, which is air. And just as our breath animates us, he thought air encompasses and sustains the entire cosmos, a kind of cosmic breath.
That's quite an intuitive connection. Breath equals life, air equals cosmic life. Right. But the really significant thing Anaximenes did, why it's arguably a refinement, is that he proposed a clear mechanism for how this one substance, air, could turn into everything else we see. He introduced the processes of rarefaction and condensation.
Ah, okay, so he didn't just say it's air. He explained how air becomes other things. That feels like a big step towards physics, doesn't it? Explaining the process.
Exactly. That focus on process is the game changer. He said when air is rarefied, meaning thinned out, made less dense, it becomes fire. You can sort of see that, right? Hot air rises, it seems less substantial, associated with flame, and conversely, when air is condensed, thickened, made denser, it transforms step by step into other things. Slightly condensed, it's wind. More condensed, it becomes clouds, then water, then earth. And at its most dense, it becomes stone.
You can almost picture that, like squeezing air tighter and tighter until it becomes solid.
Right. It's based on an observable quality density. So Anaximenes provided this dynamic mechanism based on changes in density for how the single arch could differentiate into the whole diverse world. It answered not just what things are made of, but how they change and form. That's crucial for understanding physical processes. It made his theory seem more empirical, maybe more testable, than Anaximander's very abstract aperon. It was grounded in observable changes in a familiar substance.
And he kept that connection between the human soul and the cosmos.
Yes, absolutely, that idea. Just as our soul, being air, holds us together, so do breath and air encompass the whole world. It links the individual human, the microcosm, directly to the universe, the macrocosm. It suggests the same fundamental stuff, air, and the same processes, condensation and rarefaction, operate on both scales. A unifying principle for everything, from our own life force to the structure of the cosmos.
So how did his cosmos look? If everything is air, how did he picture the earth and stars? Still no gods pushing things around.
No gods needed in his mechanics either. He pictured the earth as flat, like a round table or a disk, and it floated on air, like a leaf floats on water or air currents. Air pressure held it up, and the sun, moon, stars. He thought they were also flat, fiery bodies, maybe like fiery leaves or disks themselves. And crucially, they weren't moving on their own or being driven in chariots. They were carried around the earth by vast air currents, like, as the sources say, hats on heads being blown in the wind.
Hats on heads. I like that image. Again, it's wrong, but it's a natural mechanism. He's proposing air currents based on something observable on Earth.
Precisely. He's trying to explain celestial mechanics using principles analogous to things we see every day, like wind. It's another step towards a purely naturalistic cosmology.
Now, it's interesting. You mentioned the sources say Anaximenes was actually more admired in antiquity than Anaximander. Why do you think that was? Because Anaximander's ideas about the epimon and evolution seem so much more profound, maybe, to us now.
That is a great observation. And yes, ancient sources do suggest Anaximenes often got more recognition later on than Anaximander. Why? Well, we can speculate. Perhaps his theory just felt more intuitive, more relatable. Air is something real, tangible in a way, even though invisible. We feel it, we breathe it. It's easier to grasp than the totally abstract, undefined epeiron. And maybe more importantly, his mechanism of rarefaction and condensation offered a clearer, more seemingly observable explanation for how change happens. You could almost picture it. Anaximander's aperon was brilliant, but highly abstract. Maybe it felt less explanatory in a practical sense to people back then. Anaximenes provided a more concrete, mechanistic picture that might have seemed more satisfyingly empirical. It offered a clearer path from the one substance to the many things.
Okay, so let's pull back a bit. We've got Thales with water, Anaximander with the boundless apeiron, and Anaximenes with air. What's the big takeaway here? Why do these Milesians matter so much? What does it all mean for us, today? These ideas might seem crude now.
They absolutely represent a foundational shift, a monumental shift in how humans approached understanding the world. These Milesians, together, they kicked off the move away from explaining everything through myths and divine actions towards naturalistic inquiry. Inquiry based on observation, on reason, on looking for causes within the universe, not outside it. Instead of God's unpredictable whims, they sought universal principles, underlying substances, things operating by their own inherent logic. That focus on internal natural causes that our own minds could uncover, that was profoundly revolutionary. It's the bedrock of Western science and philosophy.
And just the sheer courage to even ask those questions, right? To challenge centuries of belief, to basically say, maybe the gods aren't not directly involved in sunrise.
Immense intellectual bravery. Think about questioning the stories everyone grew up with, the beliefs that structured society, the explanations sanctioned by religion. To seek universal principles that worked without divine intervention was radical. Their courage paved the way for everyone who came after. They showed it was possible to ask these questions and seek rational answers. They laid the groundwork. Even their mistakes, their primitive theories, were vital starting points. They stimulated more questions, more thinking, and gave later Greeks in math, astronomy, biology a framework to build on or react against. They started the whole conversation.
And the sources do say later philosophers called their ideas crude, but that's okay, right? First attempts often are. They're like essential thought experiments.
Exactly. Crude from the perspective of Plato or Aristotle, who had centuries of thought building up, sure. But that doesn't lessen their importance one bit. They were essential thought experiments, the first systematic attempts at a rational cosmology, a natural philosophy. Subsequent thinkers could then analyze them, critique them, refine them, build something more complex. The very act of trying to find a natural, unified explanation, even if the specific answer was wrong, that was the breakthrough. It showed the power and potential of that whole approach. And it's worth stressing again, as the sources point out, this Greek philosophical path seems to have developed largely independently. Yes, they learned math and astronomy from Babylon and Egypt, but the philosophical framework, the search for the arch, the move towards naturalistic explanation, that seems uniquely Greek. It set their intellectual trajectory apart from other ancient cultures, where knowledge often stayed more closely tied to religious authority.
So let's bring it home for the listener. For you listening right now, what's the relevance? Why should Thales, Anaximander, and Anaximenes matter to someone living in the 21st century? Water, boundless air. What's the connection?
The connection, the aha moment, is that the fundamental questions they were asking are, in essence, the same questions driving science today. What is the universe ultimately made of? How does it work? What are the fundamental forces? How does change happen? Where did life come from? Whether scientists are searching for the Higgs boson, a theory of everything, exploring quantum mechanics, dark matter, or the origins of life on other planets, it's all fueled by that same fundamental curiosity, that same desire to understand the world through observation, reason, and finding underlying principles. The Milesians approach: look for natural causes, look for mechanisms, assume the universe is intelligible. That is the spirit of science. Their legacy isn't necessarily their specific answers, water, air, apeiron, but the way they ask the questions and their belief that answers could be found within nature itself.
Every time a physicist proposes a new particle or a biologist investigates evolution, they're kind of standing on the shoulders of these guys from Miletus.
In a very real sense, yes. They gave us the permission, the intellectual framework, and the courage to even start asking those questions in a systematic, rational way. They showed us the universe wasn't just a mystery ruled by gods, but potentially something understandable.
So we've taken this deep dive into the Milesian School. We've seen how Thales, Anaximander, and Anaximenes in that vibrant city of Miletus dared to look past the myths, to ask these huge fundamental questions about reality itself. Their answers might differ: water, the boundless air, but that shared commitment to rational inquiry, to looking for natural explanations. That really did lay the foundation for so much of Western thought. It lit a spark that's still going.
It truly did. They started a tradition of critical thinking, of naturalistic explanation that defines how we try to gain knowledge even now. Their insights, even the crude ones, showed a path where the universe could be understood through reason, not just accepted through faith or story. They empower the human intellect.
So here's something to think about, maybe mull overs later today. The Milesians, with their, relatively simple questions and their first stab answers, they put humanity on this path of nonstop intellectual exploration. They made the universe seem noble, right? So with all our amazing science and technology now, are we still deep down wrestling with the exact same core questions about the ultimate stuff and rules of the universe? Or maybe think about it this way. Did the Milesians' fundamental belief that the cosmos is ordered, knowable, explainable through natural means, did that belief itself irrevocably shape not just philosophy, but the entire path science took afterwards? How much does that initial spark of rational questioning still echo in every new discovery we make? It's kind of incredible to think about its reach.